We've held a lot of GOTO conferences across the world and collaborated with some of the top creators and innovators within software. In this brand new GOTO Book Club, we give you key takeaways from the masters themselves in the form of interviews revolving around books they've created. Learn strategies and how to become a more efficient developer as we dive into the first online series of our GOTO Book Club.
This episode was made possible thanks to Humio. Humio is the market leader in real-time logging and analyzing data. Visit humio.com for more. Welcome to another episode of the GOTO Book Club. Earlier today we had a wonderful conversation with Richard Feldman and Thomas Anagrius. Richard is the author of Elm in Action. Thomas is lead developer at Humio and one of the very first and early adopters of Elm. We kicked off the conversation by asking Richard, what is Elm and will it eventually take over the world?
What is Elm? So Elm is my favorite programming language. It's a language for building web apps, building web app UIs. So specifically like building UIs in the browser, and generally it's used for building web applications as opposed to, for example, just adding a little bit of interactivity for a static page. So Elm compiles to JavaScript, so you can use it instead of JavaScript. Also, it has JavaScript interop, so if you want, you can use it in conjunction with JavaScript. The most popular way that people introduce Elm to an existing code base is that they will start off with an existing JavaScript code base in like React or Angular or Vue or something like that, and then they'll introduce just a little bit of Elm and then see it grow and grow and grow, and then maybe eventually it sort of shifts to where their code base becomes majority Elm, and then eventually, almost all or entirely all Elm. That's what we did at my job back in 2015. And so now 5 years later, we have somewhere around 400,000 lines of Elm code and very, very little, almost no remaining legacy JavaScript code. Still a little bit. So yeah, it's a type checked language. It's purely functional and it's got a lovely user experience, I think.
Will Elm eventually take over the world?
Yeah, that's a great question. Personally, I think that Elm will become popular, but not the most popular. I think it's sort of seen a slow and steady growth, kind of like Python did. So Python came out in like the 90s, but initially it was not a very widely used language. It just kind of slowly and steadily grew, and then it became used in more and more different domains, and then eventually it became quite popular. Now it's sort of among the most popular languages. But I think when it comes to building applications in the browser, it's going to be, it would take something really serious of a change for something that's not a JavaScript dialect to like take over the world, as it were. JavaScript just has so much momentum. Having said that, for me personally, like having spent a lot of time with Elm now, I just can't imagine myself taking a JavaScript or TypeScript or CoffeeScript job ever again. It's really just, if I'm building a web app, I'm doing it in Elm. And I think that while also thinking that Elm's not going to take over the world, because as we all know, popularity is determined by a lot more things than just sort of technical merit. So I think it's a great tool for me to use, and I'm very happy to teach it to other people. But at the same time, I don't think it's going to be number one in terms of popularity. That's my prediction at any rate.
Well, maybe comparing it to Python is not the best comparison either, right? Because that's a general programming language, whereas True. Elm, and I think that's one of the big strengths for Elm, is that it was tailored to doing web applications, right?
That's very true. Yeah.
So I think you're right. I don't think Elm is going to take over the world either. And I think that it's a somewhat niche language.
It's focused.
It's very focused, and it's very deliberate, and it's very opinionated in how it does things. And I think the very popular things that you see out there are more general, right?
Yeah, they have sort of a broader scope.
And I think a big part in the on the web platform is that JavaScript is the assembly language of the web, right? And as long as it will remain that, people are going to write in JavaScript or
Sure.
things that are close to it, because there are so many benefits to just being able to run the code directly in the browser. You don't quite get that in Elm, right? You are quite far removed actually when you execute the code that's being executed from what you write.
Yeah, and I mean that's something I like about it is that it's sort of an escape from JavaScript and TypeScript and that whole ecosystem and all the complexity of it.
Definitely. I mean, one of the things that struck me a couple of months ago is that we have at Humio a code base of 100,000 plus 200,000 lines of Elm code, and we have like 12 dependencies. And
Yeah.
yours being some of them, like Elm tests, for instance, right? But
Nice, yeah.
but in a similar JavaScript application, you would have hundreds of thousands probably of dependencies, and I'm not even joking there, right? Which is the sad part of it. And I mean personally, when things go wrong, or when I start to hack in my code, is usually because I need to hack around something that comes from a dependency. Right? So when it's your own code, you don't really need to do that. And sure, it's a little bit more effort, but in the long run, it's worth it, right?
Yeah, I mean, I would take that on a case-by-case basis. I mean, certainly some packages that I get, are really valuable. But yeah, definitely there's a cultural difference where in Elm, I think you don't get this micro package thing that you see in the NPM ecosystem where people write, left pad being the most famous example of that, where you have this it's like a one-liner. Someone made a package out of that. It doesn't really happen in Elm, or at least not from what I've seen. And yeah, I appreciate that. I would, if it's just a one-liner, I'd kind of rather write it myself and not have this ballooning explosion of dependencies. I think I don't know if we've quite crossed it yet, but we're very close to 400,000 lines of Elm code at work. And we still have under 100 total dependencies, like direct dependencies as well as their dependencies. Like if you add up all the dependencies we download on a clean build, it's less than 100. I think that's normal for Elm. It's you don't really see that same explosion of dependencies, which is kind of funny because considering you got Elm's dead code elimination that's like so much better than what's possible in JavaScript, you would think the downside of getting more packages would be less, like because you don't pay for it in terms of compiled asset size, and yet like we have that great benefit as well as not having to deal with the mental complexity of having so many dependencies to keep up with.
Takeaway number 1. Elm is an escape from the complexity of the JavaScript ecosystem, having a significantly lower number of dependencies.
I think it's also, it might also be one of the things that's a little bit scary about Elm, because for new people, like I often encounter people when they're just starting out in Elm. They say, why is everything so hard? And of course, I don't think that they're so hard.
If something's new, then of course it's unfamiliar. It's by definition harder than what you're doing. Before.
But I think that there's more than that, though, right? Elm is a very, as I said before, opinionated in how it does things, and it's very restrictive. You can't just go out and touch the DOM willy-nilly, right?
True.
And like you're used to in JavaScript, So getting these or hitting these roadblocks I think is a source of frustration for people because you don't understand it, right? As you said.
One of the motivations for writing the book is giving people, like beginners in particular, a way to understand how to not just learn the syntax of the language and the concepts behind it, but actually learn how to build things with it. Because like you said, I mean, it is different from what you're used to if you're coming from a JavaScript background, and hopefully the book has made it easier.
Yeah, so in the book you take people from learning the basic syntax, right? Because it is not a C family language, right? So
Sure.
So
yeah.
The syntax is quite Some would say exotic, some would say arcane to what people are used to, right? And that can definitely be a factor as well. It's such a simple language at the same time, right?
It is, yeah. I mean, I would say the syntax is closer to Python than JavaScript, but it's also not quite the same as Python either. I mean, in the sense that you have, fewer parentheses, for example, than you do in JavaScript. Or maybe even Ruby, actually. But there are definitely differences. Yeah, but syntax really is, in my experience, I mean, I've taught Elm workshops as well as like online courses for front-end masters and the book. And it seems to me, based on my workshop teaching experience, that syntax is actually the quickest thing that people get used to.
Sure, yeah, exactly. It's more the way of interacting. That's what I meant, right? That you just don't go out and touch the DOM. You do things in a very strict manner, in a very strict order.
And I think before React got really popular, like the virtual DOM thing was a very unusual thing. I think now people are more familiar with that, and maybe even that's the most common thing, I would say, that people are used to. But yeah, like you said, the difference is that that's all you've got, right? That's the only way to do things. There is no like alternative fallback, let me just reach out and you take this one thing. I mean, yes, you can do that with JavaScript interop, but that's not till chapter 5, I want to say, in the book, like halfway through. But yeah, I mean that's considered very normal in JavaScript to be able to do that whenever you want, and in Elm that's a very advanced, like you need to learn several different techniques before you could do something like that, and it's of course strongly discouraged. It's not like the language doesn't want you to do that. The language really wants you to buy into the like virtual DOM concept and use that as your exclusive way of rendering things. But if you do, you get all sorts of benefits. So it's like restrictive, but there's a lot of benefits that come from those restrictions. They're not sort of arbitrary restrictions. They're restrictions with a very, very good purpose.
It's about getting people to appreciate what those benefits give you, right?
Totally.
Which is hard to see when you're just starting out.
Second takeaway, the book teaches you the language syntax by focusing on building things.
At my company, we're a lot of developers on a big code base, and I'm never afraid of breaking the code base, because I trust in compiler. I trust, right? If it compiles, it works, and that's something that a feeling that you don't sense of security you don't really see even in other strongly typed languages. Because they allow you to do like escape that safety, right? And Elm really does not.
People ask me like, well, what's the difference between Elm and TypeScript? Is Elm just like a typed language? Well, TypeScript's got types. What's the difference? And one of the easiest differences to point to, and maybe the biggest one, is any. Like in TypeScript, you have any, which is this escape hatch that means that any possible types could be a lie, and you actually can't. It's not achievable to have the same level of trust in TypeScript as you do in Elm. And that sounds like kind of an abstract thing, but like you said, I mean, the real benefit there is this feeling of like invincibility, of like I can make whatever change I want, and like once I get it to compile again, it's probably going to work again. And I've gotten so spoiled by that. I like you said, I mean, we have this huge code base and we just make big changes to it whenever we want to. Like if we think that the code's going to be better if we reorganize it in a particular way, we just do it, and then we follow the compiler errors until it works again. And usually, I mean, we don't even need to change tests unless there are also corresponding type errors in the tests. But it's not like we need to like lean on handwritten tests to give us that same confidence. Like we do have tests too, but the compiler is like 90% of what's getting us back there, and we don't even have to write that code. It's just the compiler just did it for us just because we were using Elm. Like the amount of like code cleanup that we can do in like such a faster speed has really been, for me, just something that I can't imagine giving up again. Like the ability to just say like, I want to clean my code up in this way, I'll just do it and it'll be fine. Whereas I've even in other typed languages I've used, in a lot of cases I'm like, ooh, well, if I change it, is it going to work again afterwards? Am I going to cause a bunch of regressions? I just never have that fear in Elm.
Especially when it's someone else's code, right?
Oh yeah, absolutely, right. Yeah, I mean, we have we're coming up on 100 employees at the company, at No Red Inc., where I work, and like, that's not a huge number of people. I mean, there's obviously companies with thousands and thousands of employees. But yeah, I mean, I don't know, necessarily, like, if any of my coworkers are even aware of the code that I'm writing, and I may not be aware of the code that they're writing. There's like parts of the code base that I haven't even seen before.
Takeaway number 3. The compiler ensures that no one breaks the code base, which is a great help in large development teams. Visit humio.com and start your free trial today. Log everything and answer anything in real time.
It's a good point. It's one of the things that, like, in functional languages, one of the key differences, I think, is that what you see is what you get. What you're looking at right now is what's going to happen, right? You shouldn't be afraid of changing something in the invoicing a part of the code, and it all of a sudden breaks the carousel on the front page, right? Because of side effects, because there are none when everything is a pure function, right? And that is such a game changer for large code bases, I think.
Absolutely. I mean, I usually don't mention that one when people ask about the difference between Elm and TypeScript, because it's a little bit harder to explain. But yeah, I've really felt that one when I have been comparing Elm and Rust. So Rust, I've been spending time with as well, and I like it a lot. There's a lot of great things about Rust, but the refactoring ability is just not on the same level as what I get in Elm. And it's like you said, it's because of side effects and mutation. Like Rust even has a first-class concept of mutation tracking, and they don't have any, which TypeScript does. And it was a typed language from day one, so like the whole ecosystem is typed. So in those ways, I would say Rust's type system is a lot more reliable to me than TypeScript's. But even with that, I've still had bugs where I took some Rust code and I just habitually, because I can do this in Elm without any concern, I'll just rearrange the order in which things are happening. I'm like, oh, actually, I think it makes more sense to like call this and then call this and then call this. Or I did some other refactor that resulted in code being in different places, and it didn't work anymore afterwards. It was broken, and I was like, why? How could this have broken? Because in Elm, yeah, like you said, I mean, when you have the guarantee that functions don't have side effects, you really can just rearrange them however you want to make the code nicer and really have the full expectation that it's going to work again afterwards. But even in Rust, that has not been true for me. I've definitely broken stuff just by reordering it. Whereas in Elm, I'm like, yeah, just reorder it, it's fine. If it compiles again, it's going to work. And it almost always does, to almost a shocking degree.
You can still code the wrong thing, right? You can still code the wrong thing, but it's going to work.
It's not 100%. It's not possible to guarantee that if it compiles, it just works. But it is just ridiculous how often it is. I mean, it's certainly most of the time, and it's like I don't know what exact percentage, but it feels like it's like in the like 80% plus range. That like when it compiles again, like to the point where if it compiles, I just expect it to work, and if it doesn't work, I'm very surprised. I'm like, what happened? How did this compile and then not work? Which is a hard feeling to convey because it sounds so ridiculous at face value. I mean, if you spend a lot of time programming in other languages, I mean, that's not normal.
Takeaway number 4. Functions done right don't have side effects. If it compiles, expect it to work.
One of the interesting things is that for our application, whenever we have bugs, it's usually due to CSS. Because we don't use Elm CSS, right? And
yeah,
maybe you can talk a little bit about what that is.
Oh, sure. Yeah, so Elm CSS is a library that I made. We use it at work. Although honestly, I feel like every time I bring up Elm CSS, I need to make a plug for Elm UI, which I kind of wish we were using at work, except that we just have so much legacy CSS. It would be a really great project to convert to it. But Elm UI is one of the most beloved and like most popular Elm packages. So Elm UI it was made by Matt Griffith, and basically it's a CSS alternative where basically it's a way to do layout in the browser without even knowing CSS. Like you don't have to do no CSS concepts, no flexbox, no grid, no float, no any of that. It's just a complete ground up scratch rewrite of like a layout system that works in the browser. And the way that it works is, of course, that it behind the scenes compiles to CSS in the same way that Elm compiles to JavaScript. But the point is it has a completely unrelated set of primitives. And so some of the funny things are like, I saw actually on Elm Discourse, I think it was yesterday, somebody posted like, hey, I'm entering the job market. And one of the concerns that they listed was, I got into front-end web development and I'm learning Elm, and I know Elm UI, but I don't really know CSS. And I'm kind of concerned that that's going to, be like make it difficult for me to get a front-end job, because most places, do use CSS. But I love that implication. It's just like, yeah, like if you know Elm UI, it's like CSS is a lot harder. Because we had a big React code base before we started using Elm, we have legacy CSS, and so we sort of incrementally moved that over to Elm CSS. So Elm CSS is, I guess it's similar to, it was originally styled components, I think was the one in React. But I think there's new names for it now. And I think there's one that's more closely resembles the Elm CSS UI or API, but I forget what it's called. I want to say it's Emotion, but I might be misremembering that. I've been like kind of out of the JS world for so long. I don't know the names of things anymore. But the basic idea is that it gives you a way to do type checked CSS in your front end code. And also you don't need to have a separate style sheet. So I can basically just add an attribute to any of my HTML values, any of my elements that just says CSS. And then the CSS attribute takes a list of typed CSS properties. So for example, if I want my button to have a 1 pixel border, I can just say CSS and then square bracket, because you give it a list of all the attributes that you want. And I just say like, border 1 pixel solid, blah, blah, blah. And if I mess that up, like if I mistype something in there, then I'll get an error at compile time. And then it behind the scenes will automatically generate a class, and then that's like a hash of all the styles in there, and then reference that, and so on and so forth. So yeah, it makes things a lot easier, but it is at the end of the day still fundamentally CSS. So it's sort of a way to make CSS nicer. We have, I counted at some point, it's like 600 and some odd different like typed CSS properties in there. So it's not like the entire 100% of the CSS spec, but it's, it's a lot. Whenever I see people complain about TypeScript compile times, I'm like, what's that? What's a long compile time?
Yeah, it's funny you said that, because one of the reasons, so we went for, having everything in Elm is quite a benefit, right? Having like thinking about your application as not just the behavior, but also the way it looks, because you can't really separate the two, right? In a web application. But at the time, which is now several years ago, the compile times were so excruciatingly long.
Oh yeah.
That it just it wasn't feasible to, you wanted to see how does this look when it's has a rounded corner, and you have to wait 80 seconds or something like that when you get to a certain size, right? It's not like that today, right? It's like a second. So yeah.
Yeah, like 2017 Elm compile times were not great. I think that was like everyone's favorite release of like the people who are using Elm today, but who are also using it in like 2017, like the one that just made the compiler just ridiculously fast.
Yeah.
I mean, yeah, that was a total game changer.
We went from like 2.8 minutes to 4 seconds from a full
right, and that's like a scratch build, right? Like the entire
scratch,
code base in 4 seconds. Yeah. Because like incremental compile times are usually sub-second. That was a nice release.
Takeaway number 5. Elm UI is one of the most beloved and most popular Elm packages. It is a way to do layout in the browser without even knowing CSS.
Getting back to the book, the amount of code that you end up writing in the book, even though it is one application, like so chapters 2 through 8 are all about building one application. So like chapter 1 is just basic syntax, but then throughout the rest of the book, it's all about building an application from start to finish. And then each chapter, you like at the beginning, you get sort of feature requests, from your manager, and then you implement that feature request over the course of the chapter. And then in the course of implementing that feature, you learn about the concepts necessary to do that. And the entire time, I think, unless you have, I guess I haven't tried it on like a Chromebook, but I would expect that all compile times like throughout the entire book would be less than a second. I'd be surprised if someone's machine took more than a second to compile something.
It's one thing that struck me about the book is that it is really a journey from absolute novice to being able to write a fully fledged single page application, right? Where you even cover things like web component. Like what you said before is that using JavaScript and so on is a big no-no in Elm, or at least you're discouraged from doing it.
It's discouraged, yeah.
Why would you do it anyway? And how does that work with web component?
Yeah, I mean, so Elm has JavaScript interop, but it's generally speaking, it's a fallback. It's not intended to be something that you use all the time. It's just like, if there's something that you need, like there's a particular, like there's one very specific JavaScript library and there's no Elm equivalent library of that thing, then, if the alternative is like, well, we'd have to write this whole thing from scratch in Elm, or maybe it's something where Elm doesn't have first-class support for that, like WebRTC or something like that, then yeah, you do JavaScript interop for that. But the idea is that I think most people want to have a ratio of like 99.9% Elm to like 0.1% JavaScript in their code base, or TypeScript, or whatever it is. It's not like you have like, it's 70-30 Elm JavaScript. It's like no.
It's very much like that for us as well. The things that we use JavaScript interop for is, we're a log aggregation management platform, right? Where we visualize people's logs. So we have like live charts, and Elm didn't have a fully rich featured charting library. So what we could do then is use a web component and just plot things in there and just wrap this little web component as like a micro application running inside of Elm, and talk to that through a type-safe API, which just fits in perfectly with Elm, right? Or as close as you can get to it without breaking the model.
Yeah, totally. Yeah, the analogy I like to use is that talking to JavaScript is like talking to a server, in the sense that you're sending immutable data, just sending messages.
Yeah, it's very much that feeling.
Yeah. And that's so actually the chapters are titled that way. So I think it's chapter 4 is called Talking to Servers, and then chapter 5 is Talking to JavaScript. And the reason the chapter titles are that way is because they're so similar. So you learn the concepts of like, here's how to talk to a server, and then the next chapter it's like, okay, now we're going to do a very similar thing, except instead we're talking to JavaScript back and forth. I guess that's how it is with ports. But then with web components, I've talked to people in like I know people on like the React core team and the Vue core team, Angular and Ember, and when I've talked to them about web components, it seems like Elm users might be the biggest customers of web components, or specifically custom elements, and specifically just for JavaScript interop, because they're so convenient for that. Because in that case, if you're rendering something and you want to be like, I want to take this JavaScript widget of some sort, like I have like an embedded calendar or something that I really like, or because like there's Elm visualization libraries. There's a lot more robust now than they were in 2017, but and then there's also like calendar, date picker type things. But let's say there is some JavaScript thing that you really want. Google Maps, that's a good example. There definitely is not a Elm. I can't imagine anyone ever going to all the trouble of like doing an embedded Google Maps in pure Elm. That would be very impressive. And actually, I think there was an Elm Europe talk a couple years ago about doing a pan and zoom type map, but it's not like the full featured map thing. But if you wanted to embed one of those, yeah, I mean, the way that I would do that is with a custom element. And yeah, it's really convenient for that. And yeah, the book goes into how to do that. I used both a custom element and also ports in the JavaScript interop chapter, because I think they're both useful techniques to use. Like you use them for different things. Like custom elements are more for visual things, whereas if you need to just talk to a JavaScript library that's going to do some calculations or whatever, or some sort of like a common thing that people will do is if they've got like an analytics provider, like Rollbar or Bugsnag or something like that, that provider will provide some JavaScript library that just automatically does all the correct talking to their server thing. And people will just talk to that out of a JavaScript port rather than writing an Elm specific wrapper. Like there's a couple of wrappers like Elm like entirely Elm wrappers for like Bugsnag and Rollbar. But I don't know about there's a lot of services out there, so they probably don't all have pure Elm implementations.
Takeaway number 6. The book is one big hands-on example building a complete application from start to finish. Visit humio.com and start your free trial today. Log everything and answer anything in real time.
One of the biggest takeaways I think that I have from using, like, so if I were to never touch Elm again, and I still think I've benefited from being an Elm developer, because the focus or the way that I write Elm is I start by modeling things, right? Really modeling the problem. And I don't think that I've ever done that in any other language or platform. And I wonder whether that's because of necessity or because why that is, right?
That's a good point. Yeah, just like getting the data model right, like getting the data. Yeah, and
in Elm, it is so beneficial to the famous phrase, make illegal state unrepresentable. But it's not just for Elm, right? It's something that go into Java and you can do exactly the same thing and get exactly the same benefits. But you just don't feel the pain as much if you don't do it. And I think that's because in Elm, you have to handle every contingency. Like,
right.
If your model allows you to both have a field says you got a server error and another where it says here's the successful data, right? Those two are incompatible.
Right, you got to remember to handle the failure possibility. Yeah, the compiler tells you about edge cases. It's not like you find out about them, way after the fact, after it's like a bug report. It's like you find out about it when the compiler tells you didn't cover this case. And then, yeah, I totally agree. I also don't. I would say Rust is maybe the only other language where I've done that, because Rust and Elm have similar like type system capabilities in terms of like sum types and product types. But yeah, it's definitely changed the way that I've thought about programming, like for the better. I definitely think that the way that I write Elm code is just more robust and better. Like the language sort of guided me to do that. I don't think that was like a thing that was just like a cultural phenomenon that people just decided to do. I think it's like the experience of using the language, I think it just makes me move in that direction, and it's a good direction.
Takeaway number 7. Elm has changed the way I thought about programming for the better. Even if I wouldn't touch Elm again, I still think I would have benefited from being an Elm developer. This has been amazing. Thank you, Richard, and thank you, Thomas. And see you next time in the GOTO Book Club.